Tonight we're going to look at 6.7 a little bit more. We're going to look at more with the trapezoids, kites, and rhombuses in terms of their area. So hopefully you remember the relationships with these different figures and their sides or their diagonals, you know, what's congruent, what is bisected, what are perpendicular, stuff like that from chapter 6. Maybe even pull out your foldable to see if you need to refresh on anything, if you still have that from last semester. But let's go ahead and move on to trapezoids. So we have this trapezoid here. Remember, we have two bases in this picture, the top and the bottom. These are the parallel sides of the trapezoid, and then you have these two, the left and the right. Those are called the legs. Okay, so for the area formula for a trapezoid, you're going to add up the lengths of the bases, and you're going to multiply that by the height of your trapezoid. Now, you just have to remember your height of the trapezoid, you have to be perpendicular to both bases, okay? So you're going to add these bases up, multiply by the height, and then divide by 2. Okay, and that's the area formula for a trapezoid. And then we just talked about this, where your height must be perpendicular to the bases. Now, in some cases, you might have to just figure out what the midsegment is. And in order to figure out the length of the midsegment, all you're going to do is take basically the average of the bases. You're going to find the middle of those two bases. So that's just going to be base 1 plus base 2 divided by 2. And it doesn't matter which base you put first. You can start with the bottom or you can start with the top, whichever one, because it's addition. It doesn't matter what order it goes in. So area formula and then the midsegment formula for trapezoids. Okay, so hopefully that makes sense. All right, so here's an example. So we have to find the area of an isosceles trapezoid. So hopefully remember what it means to be isosceles. I'm going to grab a pen here real quick. So if this is an isosceles trapezoid, I know my bases cannot be the parts that are congruent. So the legs will be what's congruent there. Okay, so this part will be 6 as well. Okay, so what you need to figure out is the area for this. So I know that area is equal to the height, which I don't know, times base 1, which I'll call 8, plus base 2, which is 12, and then you're going to divide by 2. Okay. All right, so think for a second on how you're going to get that height. Look at the picture. Look at what we could do. See if there's a way that you can come up with getting that base. Okay, and if you think about it, hopefully you thought about drawing another line right here that's perpendicular, and then we could form this little square, which that will be 8 in between those two lines. So if we think about it, if that part is 8, what's left over? I have 4 left, but I'm not going to put 4 just on this part, right? Because then I'd still have a gap over here. So I can cut that 4 in half, saying this is 2, and that's 2 as well. Okay, so hopefully that makes a little bit of sense. So now you notice that with the height of the trapezoid drawn, you know that you have this right triangle here because these two are supplementary. So I have a leg of 2, a leg of x, that we'll put right here, and then a hypotenuse of 6. So I can set up the Pythagorean theorem to say 2 squared plus x squared is equal to 36 squared, or excuse me, 6 squared, which is 36. And then you're going to take 36 and subtract 4, which will give you 32. And let's just go ahead and get the actual height. So the height here will be 5.6, and we'll round 66. Okay? So then let's go ahead and plug that in to our formula. So you're going to take 8 plus 12, which will give you 20, times the 5.66, and then divide by 2. So you should get an area, after you plug in the height, of about 56.6. And then since this is area, it's centimeters squared. Okay, so hopefully that makes a little bit of sense. Now I want you to try this bottom one. So you have the area being 36 square feet, or feet squared, and then you need to figure out the length of that bottom base. Okay, so plug it into your formula and then just work backwards and come up with an answer, and we'll talk about that tomorrow. Okay, so now let's look at kites and rhombuses. These are really easy because the area of a kite and the area of a rhombus is going to be the exact same thing. And in all honesty, you can use any quadrilateral that has perpendicular diagonals. You can use this formula for those. So all you're going to do is take diagonal 1 times diagonal 2, and you're going to divide by 2. Okay? So you're just going to multiply those diagonals and then cut that product in half. Pretty simple. So I will do this first one, and then I want you to do the second one and bring your answer to class tomorrow to talk with your groups. So first up, we have a rhombus. I know it's a rhombus because I have these 4 congruent sides, so I know it's not a kite. All right, so I got to remember a little bit about a rhombus because I don't have the full diagonal labeled. I only have part of it. Now, if it's a rhombus, remember, a rhombus is also a parallelogram. And one thing that we know about parallelograms is that their diagonals bisect each other. So that means that this length is going to be 6 and this length is going to be 3. Okay, so they're cut in half. So then I just need to take and add the full diagonals up. So it's going to be 12, and then I'm going to multiply by 6, and then I'm going to divide by 2. So 12 times 6 gives me 72, and then cut that in half. I get an answer of 36, that's a 3, 36 units squared for this area. Okay, so hopefully that's pretty simple. You just have to remember a little bit about these, the rhombuses, the kites, and all of that in terms of their diagonals, because they might not always give you the full diagonal, and you got to remember what we learned back in chapter 6 last semester. So, all right, let's see what you can do. Here's your kite. You know this outside length is 5, this little piece of the diagonal is 3, and then this piece is 6. So try to figure out how you're going to get the full diagonals and then figure out what your area is. And we'll talk about this tomorrow. Thanks, guys. Have a good night.